In 90s, India had opened up economy. There were a lot of opportunities on the horizon. So we did research. We went and visited a few lost foam foundries in USA, Europe as well. We thought that it's worth taking this forward.
There were so many challenges that you're talking about now. Was it still worth it? Like, why keep struggling with lost foam? Like, was the USP that great?
So these were the two primary factors. We said that we will solely focus on lost foam and we'll shut down the Greensand. We were able to do massive volumes. Today we're doing 1 million pieces of camshafts and rocker arms.
1 million pieces?
1 million pieces every month.
Every month?
Every month.
How does a customer view lost foam castings? Like, what is the USP for them?
That one small change had a big impact on the process time, and right now 80% of our business comes from.
If we had to go back 27 years, maybe today, would you open a lost foam casting plant today? So if you've clicked on today's video, you already know lost foam has huge advantages, but also a very steep learning curve. So what's the best way to get started? The secret lies in finding the right technical collaborator that can help you save lakhs and crores in rejections and in time. And that's where JK Foundry Engineers comes in. Over the last 10 years, they have perfected their technology, especially for Indian conditions, and now have over 12 foundry case studies to show for it. So if this video tempts you to explore lost foam for your foundry, you can reach out to Mr. Bhargav Patel through the number below and get started in good hands. And lastly, thank you JK for making India proud. And now let's get back to the episode. Today we are sitting with Gujarat Metal Cast Industries Private Limited. We have with us Mr. Tapan Patel, right? And a very quick intro to the company. While everybody is scrambling to go after lost foam castings today, this company in fact has pioneered the technology almost 27 years back, right? Am I right?
That's right. That's right.
So to say you were a first mover in the industry would be an understatement.
True.
So you obviously, I mean, really accomplished with the technology at this point, correct? Based on the plant that I've seen. So let's just get back to the 1990s. Like, what was the opportunity that you saw with lost foam at that point of time, and how did you get started?
So, in 90s, India had opened up economy. There were a lot of opportunities on the horizon. We were looking to expand our foundry. We used to have a Greensand foundry. And we said that do we expand in Greensand or do we expand in something else? At the same time, there was an Indian gentleman, NRI, who came and gave an awareness program at IF Vadodara chapter about lost foam.
About lost foam?
Yes.
Back in the 90s?
Yes.
So he must have been like an alien at that point.
True. But that opened our eyes to a new technology. So we did research. We went and visited a few lost foam foundries in USA, Europe as well. We thought that it's worth taking this forward. And that's how we started looking for partners who could supply us equipments, technology, know-how, technical support. And yes, we started in the late 1990s.
Right. So was it all available back then as it is now? I mean, even today it's very uncommon, but back then, 27 years back?
No, it wasn't so much.
Right.
China wasn't there on the horizon at all.
Okay.
So we had to look at Europe or America. So we visited the leading equipment manufacturers of lost foam at that time, and then we settled with an English company who was making lost foam castings.
Okay.
And equipments.
Okay.
And that's how we started.
And they were completely transparent with showing you around and everything?
No, they were our technical collaborators. So they helped us. They provided us equipments.
Right.
And know-how. I worked there for a long time. That's how we started.
That's amazing. So looking back on this journey now, 27 years back, would you have said that was a pivotal decision for the company at that point?
Oh yes, in a lot of ways. We started this as a greenfield plant.
This one, the one we're sitting at right now.
Yeah, okay. This is a greenfield plant. Others today, we struggled, even with the collaborations and all that, because the technology, we had to stabilize the technology to the Indian conditions, to the Indian materials, to the Indian workforce. And it took us a while. We had to learn. A lot of people don't realize is that lost foam is the only technology where there's a foreign material when you're pouring metal. Every other technology, if you look at it, is having a hollow cavity.
Right.
And that's the biggest challenge. How do I manage the flow of metal without it getting inclusions or trapments and all that? And that's where the struggle is for every lost foam foundry.
Okay.
And so did we. We did have help and support. And yes, we had guidance, but we also had to learn in our own way. And yes, we stabilized.
Right.
And we prospered.
Right. So if, you must have been maybe at a point where sand castings were not working in the 1970s or something to have switched to lost foam completely. Like, what was that transition phase like? Did you keep both on simultaneously?
Yes, we did.
Okay.
For the first few years, we had the Greensand plant and the lost foam plant running simultaneously. In the mid 2000s, we took a call that we don't want to run the Greensand plant anymore, and we'll focus only on the lost foam. So around the mid 2000s, we shut down the lost foam, the Greensand plant, and solely focused on this, the lost foam.
Okay. And all these castings that you were manufacturing on the Greensand were completely transferable. There was no.
Not all of them, no.
Okay. Right.
Some of them we had to stop production, and some we switched to the lost foam.
Good. I mean, that transition would have been really exciting.
Yes.
So now, obviously, there would have been a lot of mistakes, as you call them, but I think you turn them as challenges.
Yes.
Right? Better said. So what were some of those challenges that you incurred in the 90s?
So, like I said, the biggest challenge was whatever learnings we had in the Greensand was not useful over here. We had to start from scratch because the foam, which is a foreign material in the cavity, that had to be controlled so that we don't have scraps, inclusions. We quickly realized that the whole challenge to that was on the white side. When I mean by white side is the foam molding, the assembly, the coating and all that. So if we control that, then we were able to have a consistent rejection on the black side, the casting. So we had to master each and every step of the process, right from the molding, the assembly, coating, and then the cluster making. We not only had to work on the machineries, but we also had to work on the materials.
Right.
So we used to get consultants from all over the world to visit us, to help us upgrade, to help us improve the knowledge. And we also used the best materials available in the world. Even today, we procure our beads and slurries not only from India or China, we go it from all across the world, wherever we find the best fit for us.
Okay.
So our clear focus from day one has always been a consistent low rejection.
Correct.
The biggest struggle was that batch to batch we would find a lot of variation. So one by one, we set the right equipments, we set the right material, and we set the right process.
I think that's a very important thing you touched on. Consistency is not only from the casting point of view, but also in the consumables. Like, yes, you would also need consistent supplies of raw material to get those castings.
Absolutely.
So was it available in the 1970s?
No.
90s?
It wasn't available in India.
Okay.
And so we had to go all over the world. At that time, like I said, China wasn't there much. So we had to go to Europe or America to source our materials.
Right.
We started off with using Indian materials, but we quickly realized that we are not getting consistent quality because the products which were there were not specifically designed for lost foam. Like the foam material, EPS, what we call is a thermocol, right? That's available in India. It was available then, it's available today, but that has never been formulated for lost foam.
Right.
So we are using a product meant for packaging industry. Correct. Or for the cups, for lost foam, where both the functionalities are different. So the quality control by the manufacturers of the beads were very different.
Correct.
So batch to batch, we would find a lot of variations. And we quickly realized that that's not helping us.
Correct.
So we went across the world and looked where are this foam specifically formulated for the lost foam. And we started using them.
Right. Because even for suppliers, the volume of foam consumed by the industry would have been very insignificant.
That was the big
So there's no point in haggling with them to improve their quality, because you're probably a very small purchaser from that industry for
that was precisely the same answer we used to get from the suppliers, that what kind of volumes do you want? This volume is not good enough for us to make any changes in our formulation.
Correct, to customize it.
Yes.
Right.
So again, we had to go to people who had formulations for lost foam.
Correct. So as hurdles go, there were so many challenges that you're talking about now. Was it still worth it? Like, why keep struggling with lost foam? Like, was the USP that great? What exactly was going through the company at that point of time? What did you see in lost foam as transformative?
Lost foam had a cleaner environmental impact than the Greensand. For example, let's take sand, which is the biggest issue for a Greensand foundry, the disposal of sand, used sand.
Correct.
Over here, we are able to recycle the sand hundreds and thousands of times. And when we do dispose it off, it's in a very minuscule quantity. We can always reclaim the sand, but that's a more expensive proposition than just replacing it with new sand. So, but we're able to recycle the same sand again and again, thousands of times. Now just look at the waste disposal for us is a very insignificant issue as compared to a Greensand farm. That we realized in the 2000 that, going forward, as our volumes go up, this is going to be a big issue. And today, that is a live issue.
It is a problem.
All the Greensand foundries, that I think is one of the reasons why they're looking at lost foam.
Right.
Yeah. So environmental was a big thing. The second point was that we were able to do massive volumes. Like today, we're doing 1 million pieces of camshafts and rocker arm.
1 million pieces?
1 million pieces every month.
Every month?
Every month. Since there is no flashes, no burrs in this, because our tools don't wear out.
Hardly any time on fettling.
Abrasive material like sand to wear off the tool. There are no flashes. There are no burrs. Only thing we need to fettle is the ingate. So we are able to produce small castings in ultra high volume, month in, month out, without a trouble. So that's the second benefit what we had. And that's when we thought that fettling is a dirty, noisy, and nobody wants to do it.
Of course.
And even back then we were struggling with that department, which is manifolded right now to a great extent. So these were the two primary factors. We said that we will solely focus on lost foam and we'll shut down the Greensand. And yes, in the long run, it has paid off. Yes, we had our challenges. We had our testing moments. No doubt about that. But since we were determined that we had to make this a success, and we made it.
Right.
So it's perseverance in the end.
Amazing. Amazing. So the technology, of course, has gone a long way today. So what are some changes do you see that has maybe, changed in the last 20 years, technology-wise?
Today, with the advent of 3D printing, you don't need to mold foam patterns. You can get them 3D printed, especially if you're looking at prototyping or small volume batches. You can also 3D print the tools and dies for foam molding.
Right.
So 3D printed are used in two ways. Also, now you're getting quite advanced sand compaction machine for the lost foam industry, where for ultra complex and intricate shaped cavity castings, the sand can move up vertically through an opening which is at the bottom. Most of the typical compaction machine can't move the sand upwards,
right,
horizontally or maybe downwards. But you get advanced machine which can move sand up at an angle, and that can open up your market
the mold
for
design,
ultra complex components manufacturing.
Right.
Which is one of the core advantages of lost foam. So yeah, so technology has advanced, flexibility has come in. A lot of our customers want prototyping, which we have to do from the traditional way.
Correct.
Create a die, produce a sample and give it to them. But now we can just 3D print them and produce the samples for them.
So you think these advantages are why maybe the technology has become such a hot topic today?
No, I don't think 3D printing or the advanced compaction machine has got
So
anything to do.
what is it then? What is the fad about?
I think it's probably a factor of the sand disposal issue,
Okay.
one. And the second thing is that people also want to now try something different. We've been in the market for 27 years now, and people have seen success and failures of it. So they were quite skeptical in the early part of our journey. But now that they've seen that we've been around for 27 years, we've been exhibiting and they've seeing our products, they're seeing our customer profile, plus other foundries have come in and they're seeing their progress. So I think the confidence has come in that this technology has probably matured. The ecosystem has started developing in India now in terms of equipment suppliers, raw materials. So maybe that's given the confidence to Foundryman to start with lost form plants.
Correct. Right. All right. So I want to go into the mind of a consumer, because it's one thing to say that okay, foundries are adopting it, but what about the consumer side of things? Like, how does a customer view lost form castings? Like, what is the USP for them?
The simplest thing is high volumes with ease.
Okay.
Primarily because fettling is not an issue at all. For some of our castings, we don't use grinding wheels to fettle. We use lathe machines to just turn off the ingots. So fettling is one point. The second point is that a near net shape finish possible with lost form because of the tighter tolerances. We allow or we need only less machining allowances than Greensand castings.
Correct.
So that's lighter casting. You can make certain features as cast, so less machining. Lost form is coreless process. There's no core used. So to produce castings which have got internal cavities, you section the castings into slices. You mold them separately, you glue them together so that the cavities are formed. When you glue them together and coat them and cast metal into it, the casting which comes out is a one integrated piece, so which has a cavity inside. So lost form, the long-term advantage of lost form is complex and intricate shape castings.
Complex and intricate
Shape
castings.
Internal cavities casting.
Right.
That is where the core competency of lost form comes into.
Okay, so you're saying basically you would be at an advantage to a normal foundry if the item had a very intricate core,
Yes.
internal cavity. Okay.
On a commercial basis, yes, you're
Commercial
absolutely
basis.
correct.
Right.
That's where the advantages, commercial advantages, cost advantages starts coming in.
Correct.
Otherwise, see, one has to realize lost form has a lot more process steps as compared to sand casting. Now, those process steps means machines, material, labor, that is a cost.
Right.
You could say that the number of process steps is similar to investment casting, a bit less. We don't have multiple layers of shelling or coating like you do in investment. We only have one single layer. So that's the only difference. Otherwise, you have similar steps, and we don't do dewaxing in lost form. So there is a long process which we divide into the white side, which is all foam related. And once the casting, the foam pattern is invested into the flask and metal is poured, that's all black side. You knock out the casting, you shot blast it, separate out the runnerizers, fettle it, heat treatment it if you need it. That all is black side. So black side is similar to Greensand, but the white side is all completely additional process steps. So process time and process cost.
Correct.
So how do you negate that extra cost? Is by competing for multi-core items. The core cost is quite significant. The more cores, the more cost advantage you have in lost form, because
Right.
the cost doesn't go up significantly if you have, say, 10 core casting being produced in lost form.
Right.
Or you have a 2 core item being produced. So the cost is more or less similar. So the cost advantage is very significant for multi-core items in lost form.
All right.
And if you have volumes, you have a double advantage there.
Correct. So what can you give me an example of maybe 2 or 3 types of castings that definitely need a lost foam process to cast them today, like in your experience?
The prime examples would be engine block cylinder head, multi-code items.
Okay, even large ones?
Yeah, why not?
Right.
Lost foam has been developed for more than half a century ago in Germany. But it became popular by General Motors when they used lost foam for the Saturn car. And they were producing engine block cylinder heads in there through lost foam. That's how this technology became popular. So, yes, BMW still uses it to produce the aluminum cylinder heads. So, the technology is commercially fantastic for multi-code items.
Right. So I was going to ask you, I mean, next question is how does it compare in costing? So you mentioned it does add a little bit to the cost, but
Yes.
when you add in, I think the factor that you can cast very, very intricate core pieces, I think then that cost is negated.
Yes.
Is that how? Okay.
Yeah. So I'll give you an example. We had an American company coming to us with a product called Access Plate. It was an aluminum casting, but it had 4 internal long cavities,
Right.
which were only 4 millimeter thick. Now, an aluminum, to have a 4 millimeter thick and about 10 inches long, you can't use anything but ceramic cores. So you can produce the casting, but how do you decore it without destroying the casting? You can't.
Right.
So the only viable option for that product was to make it in 2 sections, glue it together and produce a casting with a cavity. So that was a good example of why sometimes certain technologies help produce complex castings.
Correct. Just to clarify, you said you can't use it, you can't cast this casting without any other core but a ceramic core because it would short pour?
No.
Cold shot?
We do not use any core.
No, but why couldn't they make it in a sand casting process? Because it would...
How do you remove the ceramic core? If a sand core would have snapped
Okay.
while pouring the metal.
Oh, because it's very thin.
Very thin and delicate.
Right.
So the only option they had was a ceramic core. But then how do you remove that ceramic core in an aluminum casting?
Right.
That was the tricky part.
Correct.
That's what I'm saying. But just to clarify, lost foam has no cores. No cores at all. It is a totally coreless process.
Correct. It's basically a replica of the casting in the sand. So
yes,
complete replica.
The foam pattern will be exact replica of the casting. Yes, you add on the contraction percentage and all that, but
right.
It is a duplicate of it.
Correct.
The casting.
Amazing. So, how do you see Gujarat Metal Cast Industries place today with lost foam on the rise, with a lot of competitors maybe burning their money and hands at the technology? Sorry if anybody is doing it. So obviously you have a competitive edge, right? You have a very good moat probably in the industry. How do you see yourself placed for the next 5-10 years? What are your activities today?
With our 27 years of hands-on experience, we're trying to make more and more complex castings for our customers. Again, that's a maturity curve every foundry will go through. Yes, a lot of new foundries might be struggling today, but they will not be struggling tomorrow.
Of course.
So we want to keep that gap between us and the other foundries purely because of the 27 years of head start what we have. So we will try and go into products where people with lesser experience will find it difficult or impossible to produce.
Right.
That's going to be our advantage, and that's what we're going to work on.
So that's the focus today.
Yes, absolutely.
Right. Is the process of lost foam also very forgiving of different alloys, like maybe steel, cast iron, aluminium, bronze, everything?
Yeah.
Okay.
We are one of the few foundries in the country where we produce ferrous and non-ferrous castings in the same plant.
Okay. Right here?
Right here.
Right.
We produce aluminium alloy castings. We produce the cast iron family, SG iron, grey cast iron, malleable iron. And we also produce steel and stainless steel. So we are one of the few foundries which can do that. So some of our customers want from the same mold a ductile iron casting and a steel casting. Yes, there's a contraction issue, but that can be solved out.
Correct.
So yeah, we can do that. People also pour bronze and copper castings in this as well.
Right.
So it is quite flexible in that way.
That's amazing. So basically, aluminium, stainless steel, as well as iron. You have
Yes,
no problem.
all of
All
them.
right, that's good. Okay, so I think you also mentioned that you'll have something called Piscast,
Yes.
right? And I think that is also something that you all eagerly taking forward. So what exactly is Piscast, like for the layman listening?
Piscast is basically our own development of a process. After 15 years of producing lost foam castings, we thought that what else can we do with the foam?
You'll really love challenges.
We do. We do.
Right.
I think challenges for Foundryman is, is accepted.
I mean, there are already enough. Why create more of them, right? Anyway.
True. So after 15 years of working on and producing lost foam castings, we thought that how do we make better castings in terms of surface finish and dimensional accuracy. So we said that we could produce investment castings, but instead of wax, if we used foam, we could produce a better product which could cater to the investment casting sector. And that's what we did. We replaced one thing, wax with foam. That one small change had a big impact on the process time and the cost, because wax is very sensitive to the temperature. So you need a controlled low temperature environment to mold the wax patterns, to assemble it, and to shell it. The foam is not that sensitive. So the biggest advantage is that we can work in an ambient environment. We do our shelling not in a controlled environment, but we dry them in an oven to speed it up. As a thumb rule, investment casting people take one shift to do one layer of shelling. We take 1 hour.
Okay.
So what would take them for a 10 layer shell, 10 shifts, we do it in 10 hours.
Right.
That's the process time advantage we have. And that's what we bring to the table. And that has a cost impact.
Of course.
We don't need that big a shed to store our patterns for 10 shifts. We don't need expensive air conditioning to manage that big plant. That's where the cost advantage comes in.
Amazing. So you're actively also looking to expand the Piscast division that you have.
Definitely.
Okay. So how does it compare with lost foam? Like, is there some amount of cannibalism in the technologies, or do you see them as two separate poles apart?
So the only commonality is the foam molding on one side. After the pouring, everything else is common. In between, once the foam pattern is produced and the metal is poured, everything else is different than the lost foam.
Right.
So that's where the major difference lies in.
Right.
But yes, the finish is amazing. It's as good as what you would find in investment casting.
Right.
So foam is cheaper than wax as well.
So I think I don't think we covered this, but what is the kind of weight range that you work with with lost foam as well as Piscast?
So right now in lost foam, we are doing maximum up to 30-40 kgs of casting.
So 30-40 kgs maximum with lost foam.
Yes.
And what about Piscast?
Piscast, we're doing around 20 to 30 kgs max weight.
20 to 30 kgs. So you're basically operating below 40 kgs.
That's
the foundry. Okay.
We are not geared up. We don't have the infrastructure to produce heavy castings.
Right.
That's something we took a strategic call that's where the volumes are. That's where we would like to go for.
Correct. So going forward, do you think that you're going to expand your capacity, or maybe you're focusing and zeroing in on mainly the sub 40 kg bracket?
No, we are open to it.
Right.
Even today, we get inquiries for heavier castings, and we always weigh that: do we need to expand to cater to this? If the volumes are there, if it justifies the investment, we surely go into it. There's no hard and fast rule that we'll never go for that.
Because you have the technology now.
Yes. It's never been the case that we had to invest for a heavier casting.
Correct.
The volumes never justified to go for it. We are able to get business for lighter castings, 30-40 kg, and we are happy with that at the moment.
Right. All right. So if you're looking at whether it's lost foam or whether it's even Piscast, what type of customers are you best catered to serve? Like what industry? Maybe it's pumps and valves, automotive, or maybe even SPM machines, construction, mining. Like what is your niche exactly for the company?
So basically, we're looking at medium to high volume customers. Right now, 80% of our business comes from the automotive OEMs, customers like Maruti or Honda or even Hero, TVS. That's where we get the huge volumes. We also do things for Mahindra. Um, for low volumes, we typically go towards Piscast. We don't prefer low volume castings in the lost foam
Correct.
because our resources are not there. Systems are not meant for low volume castings. We prefer high volumes or medium volume castings there.
Correct. So are we allowed to show some samples of castings? I mean,
Yeah, we got some over here.
So I think this is a foam.
Yeah, that's a foam which is a coated foam.
Coated foam. Okay.
Yeah, and that's the aluminum casting of it.
Okay. One sec. I'll just. Okay. So this is completely foam.
Yes.
Wow, it's really delicate.
It's very light.
Yeah, it's very light as well.
So basically, if you look at this product, in most of the lost foam literature out of America or Europe, you would find this casting there. This is like the poster child product for the lost foam.
Okay, okay.
If you
textbook example.
Sorry?
Textbook example.
Yes, exactly.
Okay.
If you had to make this aluminum casting in sand casting or gravity die, you would need a lot of cores. And this is produced in one piece, no cores, no slices, one piece. So whoever designed this in America, the designer was able to take most of the advantages lost foam had to offer. This casting also has zero machining. You can see this D-shaped hole aligns with this round hole here. There's a pin over here over which a roller slides. So there's an assembly done on this casting,
right,
and there's no machining required for it. So this is a coreless casting without machining. Assembly is done and it goes into the airport's material handling machinery.
Amazing. What about this one?
This one is an adapter for the pumps and valves. This is a casing for the pumps and valves. This is a good example for multi-slice product.
What do you mean by multi-slice?
So like I explained, lost foam is a coreless process. Now how do we create cavities? Right? I cannot create this product out of the molding. Correct. So what we do is we section the castings, we create the cavities for each section and we mold them separately. Then we glue them together once they are molded and then we take it forward. So when the casting comes out, it comes out in one piece. Otherwise, how would you create this hollow casting inside?
Right, right.
You need to slice it up.
Right. But with 3D printing, you don't have any of that problem.
No.
Right.
As of today, 3D printing has a limitation of productivity. Maybe in tomorrow that might go away, but today it's not there. So for prototyping, it's really good today. But yes, 3D printing is is developing very fast.
So this interview would be completely incomplete, right?
Mm-hmm.
If we are talking about lost foam and we don't say China.
Right.
Right. So how come there are thousands of companies in China making lost foam castings today, and what led that revolution, and is that revolution starting today in India?
I don't have very clear answer why there are thousands of lost foam foundries in China. But if I had to guess, I would say that the ecosystem for lost foam, which means the equipment suppliers, the raw material suppliers, and most importantly, the technical expertise available, is abundantly available in China.
Okay.
So anybody wanting to venture into lost foam has the comfort of starting one.
It would be like investment castings in Rajkot, similar.
Exactly, right. The same way. Right. So now slowly and gradually, India has also equipment manufacturers have started, raw material suppliers have started developing, or they importing and stocking it. So slowly and gradually, that ecosystem is developing.
Right.
It still has more growth possible. But I think this will give the comfort for Indian lost foam foundries to develop more.
I think that's an excellent point. Mainly the ecosystem
Yeah.
developing starts the industry. And also I think it's suppliers and consultants.
Yes.
Of course.
Because right now, from what I see, the consultants is the missing links right now for faster deployment of lost form. And China has, to the best of my knowledge, China has developed lost form in the last 10, 20 years. Developed in the sense, the flourishing of the lost form
Right.
industry. Whereas in Europe and America, it has been there for many decades now. So their ecosystem is also much more advanced than China is. And eventually China will get there with the more experience and more feedback they get from the customers. So it is all a maturity curve, what I'm seeing. Right now, if you want to take advanced machine for high precision, there are not many in China who do it, but there are established players in Europe and America who are able to supply that. Yes, it comes at a heavy cost, but China will get there in terms of quality and precision. India has just started that journey, but we will get there soon.
What would you say about Indian equipment manufacturers today for lost form? Like, are they at a stage where they are maybe they have the technology, or is there a lot of learning curve yet to be gone through?
Well, like with any technology, not just lost form or any new machinery you make, you're not going to make it perfect from day one. Every iteration you bring out, you're improving that machine, you're learning the technology more, you're improving on that. So everyone, the Western world went through the same process with lost form. The Chinese are going through the same process. The Indians will also do the same. You have to give them time. There's no shortcut to this unless you have a technical collaboration or a joint venture and you're bringing the latest technology by your JV partner.
Correct.
So, we need to appreciate that maturity has to be there. The same way with the foundries. Even with the technical expertise, they will need time to stabilize. And that's what we need to appreciate and give them time. They will get there.
Right. So if we had to go back 27 years, maybe today, would you open a lost form casting plant today?
Yes, definitely.
So you mean the advantage still exists, the early mover advantage still exists even today?
Yes, definitely.
All right, that's reassuring.
See, I always feel you take all the existing foundry technologies and you pit them against lost form. There is no one single foundry technology which has all the advantages and none of the disadvantages. Right? Every technology, foundry technology, has pros and cons. So for the product, you have to choose which technology is best suited.
Of course, correct.
So same way for lost form, the buyers or the foundry has to guide the buyers to choose that we are the best for you in terms of quality, finish, accuracy or dimensional tolerances and the volumes. And most importantly, the final decision maker is the cost.
Correct.
So that's where the Indian buyers need to be made aware of. And we feel that Indian buyers are not that knowledgeable about lost form.
Right.
But with the years passing, I think they will also start.
And I'm hoping this video will clarify a lot of the doubts that they have. Because I think it's really tough to be a procurement officer for castings today. I mean, you have lost form, you have Piscast now, you have investment castings, sand castings.
Right.
It's just all over the place. Shell molding. What exactly do you choose?
But I think a casting designer also has a big role to play. It's not just the buyer.
Right.
Because a lot of designers design a component based on a technology, foundry technology.
Okay.
So I think the designer and the buyer have to work together and identify process technology which gives them the most advantage. So I think the awareness also has to go to the designer.
Right.
What is possible? Because take Greensand casting. You have a parting line on which you can put the components. In our flask, we have a three-dimensional tree cluster like you would have in an investment casting.
Right.
Where you can maximize the yield in a flask. We are not restricted to the parting line because there is no cope and drag in lost form.
Right.
You can have a cluster which is fitted out in a 3D, multiple layers. and you can maximize the yield in a flask.
Right.
So that flexibility is there to the foundry, which he can pass on to the buyer in terms of yield, which in turn leads to cost advantage.
Right.
A few of our customers have worked with us on VAVE projects, whereby we have given them advantages. Certain features we made them as cast. So when it is as cast, you don't need to provide machining allowance. So lighter casting. Certain features are as cast, so no machining on that, less cost. You can also merge when it's an assembly of subsystems. If they are the same components, same metal, we can produce them in separate foams. We can glue them together. So when the casting comes out, it comes out in one piece. So there's no machining of the butting surface.
Right.
No fasteners used, no gasket used for leakages, no labor cost. Casting is lighter because there's no. So
right.
Lost foam has a lot of advantages, which we need to convey to our designers and buyers.
I think that also sends a very strong message that when OEMs are able to open their ears up and allow you in a seat at the table to the designing department, that says a lot about the capabilities of the technology.
True.
Because in a conventional process, it's run its entire maturity course, and it's pretty much everyone knows what's possible. But when Lost Foam, when you're able to go and actually design components and reduce cost, and as you said, remove not having to use gaskets and all these other things, it shows the technology is really ripe and you're really at the forefront leading it.
Yes.
So that's really a nice thing.
So the buyers, a lot of the times, once the design is frozen, gets the go ahead to go and look out for the suppliers.
Correct.
I think buyers will have to talk to the designers that they involve the purchase department a lot earlier.
Correct.
Before the design is frozen.
Correct.
That's when the foundries can help them cut cost, make the product better.
Correct. I think foundry is also becoming more of a means to, not so much of a means to an end. It's becoming just like a process. For example, today, if like maybe you wanted to choose a certain component, you would choose the foundry process to after you chose the component, but not choose the foundry first before you chose the component. I think earlier it was different.
True.
You would open a foundry and then you would look for business.
Right.
Today you choose what you want to make, and then you choose the most optimal foundry process to support that kind of demand.
Right. But my view is a bit different. I agree to what you're saying. I'm not disagreeing. But unless I want to specialize in only a product A and make millions and millions of it, or the foundry which can produce a lot of other components as well, product A, B, C, D, E, F, maybe tomorrow Z, double A. So foundries are flexible. Why just restrict to one product?
So do you think Lost Foam has that flexibility?
Oh yes, definitely. Okay. We are making more than 200 components right now. And if I had to club them into families, there would be more than 100 different varieties of casting. So there's flexibility. But I am not saying that the flexibility is only there in Lost Foam. All foundry technologies have that flexibility.
Right.
But the buyers need to get involved much earlier. It's very difficult to show an advantage of Lost Foam to the buyer when the design is frozen and there's no changes possible.
Correct.
Then we can't do much in it. So if we are involved earlier, the savings are there. But
that's something to take a note of. You're a procurement officer and you're looking to buy castings. Get the design guys involved.
Yes, true.
That's nice. So I think, Tapan, this has been really great, right? Is there anything else you'd like to add?
No, we're there to help and support grow the Lost Foam industry in India. We are also there to help and support the ecosystem.
Right.
We having so much of experience, we are able to help out a lot of people. I am willing to do that.
Correct.
GMC is there to help them.
Right. So also, I think, can you talk a little bit about your vision for the next 3 years for the company? Where do you see GMC growing?
So we are moving more and more towards the complexity of the castings.
Right.
That's where the advantages are. That's where we differentiate from our competitors on the technology curve, on the maturity curve
Correct.
of the process. And that's where we're going to play it out.
Right. All right. Yeah. Thank you so much, Tapan. This has been really nice.
Thank you for having me.
Thank you for inviting us, especially. And it's the first time we are come to Baroda here for an interview. So that's very
Thank you.
nice. Thank you, guys. Thank you. Thank you.